Hi, everybody. So we just finished a problem where we learned how to dilate a triangle, and now we want to find out what happens when a shape has already been dilated and what we do to find the center of dilation and then to find out what the scale factor is going to be. So one of the first things that I would like to see you guys do is think about that the line from B to B prime, if you were to extend that line, it should pass through the center of dilation. The same thing with E prime and E, it should pass through C and C prime and so forth. So what I suggest we do is we switch over here, and you guys with your rulers, you connect B to B prime and make it a nice long line. And then you do like, E to E prime, D to D prime, and then C to C prime. And as I'm sketching this in, you can actually see that they're all intersecting at that point over there at 2, looks like it's 2 comma 2. So we already know that, excuse me, so we already know that the center is located at 2 comma 2 because they're all supposed to intersect at the same point. So you'll always know what you've got going on there. So the next thing we want to do is now based on this, we actually want to find out what the scale factor is. So for me, I'm just going to hide all of this because this starts to get in the way of everything that we're trying to do. And I'm actually going to do all of this with Sketchpad, which is kind of cool. So I'm going to switch this back to a segment. So now I'm going to go to display, change my line color. Let's see, let's guess what that one is. I have no idea. But when you're trying to find out what the scale factor is typically going to be, new horizontal, I can't spell horizontal, over, divided by old horizontal, or, new vertical versus old vertical kind of thing. So in this case right now, we're just going to do the new horizontal. I don't know why there's a 7 sitting right there, but okay. So the first thing that we're going to do, and this is all to get us a scale factor. If I'm looking at B and I'm looking at B prime, or I'm looking at C or I'm looking at C prime, I'm going to focus on just the horizontal right now, and then we can eventually do the verticals. But the first thing I'm going to do is I'm going to take my distance here, and I'm going to go from here to here to do my vertical. I mean, it's not my vertical, it's horizontal clearly. And if we count the distance from the center out to point B horizontally, it's 1, 2, 3, 4, 5, 6, 7. I guess where that 7 came from. I guess you guys figured out. You're on to me that I've done something. Okay. Now the next thing is that B prime, if you look up here, is at negative 6.75 comma negative 1.75. So if I were to take my trusty thing here and do the same thing and go out to this point right over here, that distance would be 1, 2, 3, 4, 5, 6, 7, 8.75. So this distance is 8.75. And again, this is equal to the new. And this guy right here is equal to your old. So stretch you out, okay? And then the scale factor is going to be the ratio of the old divided by the new. So if we do a little fraction here, so if we do 8.75 divided by 7, according to this, if I do 8.75 divided by 7, 0.75 divided by 7, I get 1.25. So my scale factor, according to this, is 1.25. Okay, and that's going to be my scale factor. But we're going to confirm that because we should really check to see if that works for other distances. Okay, so right now we're just saying it is because I did the new horizontal distance from the center, because again, this is our center right here. So our center is right there. And I just wish I was such a good typist, and I'm not. I guess you can't be good at everything. So your center is over here at 2, 2. Let's not lose sight of that. So now, like, let's say hypothetically we want to do it with like C and C prime, okay? And let's do it vertically. So if I were to take my thing here and go down vertically to point C, and then do the same thing, down to the C prime, which is that way. So we can go ahead and just count what those are. And again, you're looking at C prime, and C prime it says is at negative 0.5 comma negative 3. So from the center, and I'm going to change these 2 colors because I can. I don't know what color they're going to be because again, I just don't understand why the colors never showed up here. So it looks like they are maroon, or they look like magenta, whatever. So if I look at, let me move this over here. If I look at this distance from my center down to C, which is the original, I'm going down 1, 2, 3, 4. So this is 4, which is equal to my old, right? So the 4 is the old. And then the new is you're going down 1, 2, 3, 4, 5. And that's going to be 5. So again, and that's equal to my new. And again, just to really send it home, you know, we're going to go back in here. Sorry, guys. And we're going to do the new divided by old like we did up top there. And that's going to be equal to 5 divided by 4, which is equal to 1.25. So again, we have verified not with 1 point horizontal, we actually verified that it's going to work whether we go this way or we go that way. So we can now fairly say that that scale factor is actually going to be equal to 1.25. I'll be right back for another one. So this particular problem, it says the line segment AB has those two endpoints, lies in the coordinate plane. It's going to be dilated by a scale factor of 7/5. And the other center is at -8.5 to create A prime, B prime. What is the new length? So the first thing I want to do is we're going to plot the points. So we're going to plot -14, -7 plot. And we're going to plot, let's see, 14, 7. Whoops, 14, 7. And we're going to plot that guy. And we're going to hit done for now. And we're going to connect those two. And 7/5 means it's actually going to be bigger. So we might actually have to zoom in a little bit more because I have a feeling we might actually fall outside of our realm, and I might actually just move this up a little bit so we can actually see what's going on here. So I'm going to mess around with it. Okay, the next thing I want to do is we're obviously going to plot the center, which we have at -8, 5. And we're going to plot that, and we're going to be done. So by the way, 7/5 is 1.4. So in other words, it's going to be 1.4 times bigger, which means this thing is obviously going to be longer on this guy. So first thing we do, like we did before, we do that vertical and horizontal distance. So if I count from, and we'll actually put it in here. So I'm going to count out to A. And what I'm going to do this time, and I don't like that it's doing D. I don't want that there. So get that out of there. We're going to count that out, but what I'm going to do is we're going to make that a dashed line so it doesn't get all weird and creepy. So that's going to be dashed. And then we're going to do the same thing down here and that guy right over here. So now if we count it, we're going to go 1, 2, 3, 4, 5, 6. And now the other thing that I want to show you is, if this is -8, 5 right over here, and we're going over to -14, 7. Here's what we can do, guys. If we know how to count, we should be good, right? So instead of counting the boxes going across, right? And I'm also going to put 14, 7 over here because I can. So we're going to put 14, 7 over here. All right. So instead of counting boxes, because that can start to get annoying, you're going from your x's horizontally. You're going from -8 to -14. If I asked you how far do you have to go from -8 to -14, you're going to say 6, right? And then vertically, you're going from 5 all the way down to -7. So you're going down 5, and then you cross the x-axis, and you're going down another 7. So that's going to put you at, you guessed it, at 12. So now we're going to multiply those by that scale factor, right? So we're going to multiply this times 7 divided by 5, okay? Going backwards. So 6 times 7 divided by 5. And you should do that on your calculators also. And it's pretty much doing the same thing as 6 times 1.4. And that's going to be 8.4. So this is going to be 8.4. And we should all know that that, represents how far we're going across from. I'm going to move this up here. So come on. I'm going to move this up here so I can actually see what I'm doing. All right. So it's 8.4 units from that center. And then I'm going to take my 12. And again, I'm going to multiply that times 7 over 5, which is 1.4. And then if I do that, so 12 times 1.4, I get 16.8. Okay, so that's equal to 16.8. So now if we want to figure out what the ordered pair is, right? the new ordered pair because we're going by decimals. From here, just look at this. We are going from -8, we are going to the left another 8.4 to the left. So we are doing -8 minus 8.4. So you should be telling me that that new x-coordinate is going to be, you got it, -16.4. Okay, so that's going to be the new one. And then, let me go over here. So that's going to be the new ordered pair for the x-coordinate. And then the y-coordinate, you're going 5, but you are subtracting 16.8 because from here, you are going down 16.8. So 5 minus 16.8 puts you at, I'm sorry, 5 plus 16.8. Yeah, so 5 plus 16.8 puts you at -21.8. So this should be -21.8 because you're going down. So, and we are clearly running out of, no, did I do? Oh gosh, all right. So it's not -21.8. It's, oh my God, yeah, I was right the first time. 5 minus 16.8 is -11.8. So we're at -11.8. You know what? I was looking at the -14 and it just confused me for a second. So again, I did -8 minus 8.4 and got -16.4. And then I did 5 minus 16.8 and I got -11.8. So that's my new ordered pair, okay? So down over here, so 15, so I'm going to actually just plot it now. So on my graph, I can just go ahead and plot points, -16.4, and then -11.8, and I'm going to plot that point right there. And where is it? You can't even see it, so I'm going to have to just, if I can just move this up a little bit. There it is, okay. I'm going to move that up there for just a second. Hide that because it's in the way. We're going to hide that in the way, but we have those ideas. Okay, I didn't plot those actual points, which is why things are moving on us. Okay, so we have, let me just move this a little bit more because you can still see that we still cannot, there we go. Okay, so then to do the C over here to B, I think I want you guys to do that. You're going to go up 2, right? And you're going to go to the right. You're going from, by the way, you're going from 5 to 7. If you look at this, you're going, your y-coordinate, you're going up 5 to 7. So that means you are going up 2. So that's going to be a 2. And then you're going from -8 to +14. That is a long distance. And I hope you realize that that distance is going to be 22. Whoops. So that's going to be 22. So again, if you put in, you know, if you do your little thing here and you're just going across and filling those out, that's what you're going to do. And then you're going to multiply those by 7/5 and 7/5, and you guys tell me what your new values are that you come up with. I'm going to hit pause real quick, and I'm going to do a quick math, and you're going to do the same thing. I should have gotten 22.8 and 7.8 after multiplying 7/5 times 2 and 22 times 7/5, and you're going up 2.8 from C, and then you're going to the right 30.8 from there, and it should put you there. Now, if you want to actually find the length of this, instead of actually finding the length of this segment here, come on now, stop being such a pain. Okay, it's going to be somewhere over here. I don't know why it doesn't want to acknowledge you, but okay. The best thing to do, honestly, if it were me, instead of actually finding the length of this dotted segment, I would find the length of AB and then multiply that times, you guessed it, by 7/5. So here's what we're going to do. First things first is I'm going to, you draw that vertical, and we're going to do Pythag swag for this, you know, and go up here. But the first things first is I don't like that these are dotted lines because it's a little confusing. So yeah, I'm going to hit pause. I'll be right back. You have noticed that the lengths of the sides are obviously equal, and they're 21 and 21. And when you do Pythag swag for the original segment, you get 29.70 as your answer. So that means then that A prime, B prime, or yeah, A prime, B prime is going to be equal to 1 is going to equal 7/5 times that length, that 29.7. And that's going to give you, so 29.7 times is going to be 41.58. So in other words, the nice thing is if you find the length of the original segment and then multiply it times the scale factor, you will get